All right. So we're doing 1.5 today, which is rewriting literal equations. A literal equation is just an equation where variables represent known values. Literal equations, some of the common ones we have are for temperature, changing between Celsius and Fahrenheit. We have simple interest and compound interest are formulas that we use. Distance is equal to rate times time. All of those are going to be considered literal equations. So what we're going to be doing today is trying to rewrite it to get one of the variables by itself. So let's take a look at number 1. It wants us to solve the literal equation for y, which means we want to get y by itself. So the first question we need to ask ourselves is, what's keeping y from being by itself? It's that negative 2x. So that's what we want to get rid of. It's attached by subtraction. So we're going to use our inverse operation and add a 2x over to both sides. So when I do that, my 2x's cancel out, and I'm left with y is equal to 15 plus 2x. That's it. That's our answer. There's nothing else more that we can do on this one because we just want to get y by itself. 15 plus 2x are not like terms. We cannot write that as 17 or 17x. Those are not like terms. We have to leave them separate. Okay, let's go to number 2. So again, we're trying to get y by itself. There's 2 things keeping y from being by itself this time. We've got the 8 and we've got the 5. The same rules apply that we've been learning all school year long. We want to get rid of the addition or subtraction first. So I'm going to start by subtracting the 8 over on both sides. So I have 5x minus 10, be careful with that subtraction, is equal to 5y. Okay, the only thing left keeping y by itself from being by itself right now is the 5. So we want to get rid of that 5 next. So I need to divide by 5. But when I divide this side by 5, I actually have to divide the entire side by 5, which means I'm actually dividing this and this. Both parts are being divided by 5. So these 5's cancel out, which gets y by itself, which is what we want. And now we need to do the math on the other side. So we're going to actually do this division and this division. We have to do both parts of that. So 5x divided by 5, well, 5 divided by 5 is 1, so I'm left with just a 1x or an x, minus, and then 10 divided by 5 is 2. And it's okay to leave your answer like this. Some people are going to want to rewrite it with y on the left-hand side of the equation instead of the right-hand side of the equation. Those are both equivalent. They mean the exact same thing. It doesn't matter which one you write it as. And that's it. Again, we're used to getting y equals a number or x equals a number. But in this case, that's all we have to do. We just need to get the variable by itself. If there aren't any like terms, then we don't have any like terms to combine. All right, so for the next one, we're trying to get x by itself now instead of y. So first of all, we've got some like terms that we can combine. What is 10x minus 4x? Well, that's 6x. So I have y is equal to 6x. I'm trying to get x by itself, not y this time. So the only thing keeping x from being by itself is the 6. It's attached by multiplication, so we're going to use division. So I get x is equal to y over 6. One thing to be aware of, another way to write that is a 1/6 y. Because multiplying by 1/6 and dividing by 6 are equivalent. They mean the same thing. So both of those answers would be 100% correct. Okay, our next one's a little bit harder. As we look at this, our first instinct might be to combine our like terms because they both have x's. However, this has a z on it as well. They are not like terms. You're not going to be able to combine these together because they're not just both x's. This one has an xz on it. So we're going to use the inverse of the distributive property. We're going to factor out what they have in common. Both of these terms have an x in common. So I'm going to write an x down. And then in parentheses, I'm going to put what I have left over when I factor an x out of them. So if I'm thinking about what 3x is when I pull away the x, in other words, what's 3x divided by x, I'm left with just 3. And then I do the same thing with my 9xz. When I pull the x out, I'm left with a 9z. Okay? The reason this is helpful is because now I have x times some value. All I have to do is divide by what that value is. Okay, so my parenthesis cancels out my other parenthesis. But if I do it to one side of the equation, I have to do it to the other side of the equation as well. So now I have x by itself, and it's equal to q divided by 3 plus 9z. That's my answer. That's it. That's all I can do on it. I know it doesn't look simplified. It doesn't look like a final answer, but it is. That's all we can do on that problem. Okay, so number 5, similar idea, but this one we want to actually subtract the 4 over first. It doesn't have the variable we're trying to get by itself, so we want to get rid of it. We want to move it to the other side. Okay, so now we can use our inverse of the distributive property. We can factor out what they have in common. So what do 7x minus 5x have in common? They both have an x. So let's factor an x out. When I factor an x out of 7x, I'm left with 7. When I factor out an x out of sx, I'm left with an s, and be careful, that's an s, not a 5. That's why I don't always like using s's as variables. It looked like a 5, so we want to be really careful with that. Okay, so now to get x by itself, I'm going to divide by what it's being multiplied by, which would be 7 minus s. If I divide one side by it, I have to divide the other side by it. So my 7 minus s is cancel out. I'm left with x by itself, and then I'm left with an r minus 4 over 7 minus s. That's it. That's all I can do. That is solving a literal equation. We're getting the variable by itself. The answers may not look super simplified, but they are. That's the most that we can do with them. Okay, so let's take a look at number 6 now. We've got x's on both sides, so we want to fix that problem and get all of our x's on one side. So I'll subtract my 4x over. I have y is equal to 6x minus 6. We're still trying to get x by itself, not y though. So I'll add the 6 over. So I'm left with y plus 6 is equal to 6x. And then to get x by itself, I need to divide by 6. So when I divide by 6, well, y divided by 6, again, we've talked about is the same thing as a 1/6 y plus, what's 6 divided by 6? Well, 6 divided by 6 is just 1, so we can simplify that part of it. And that's our final answer. Okay. So we've got some formulas that are common formulas that we can solve to get a variable by itself. So to get a b by itself on number 7, we've got to get rid of the 1/2 and we've got to get rid of the h. So I'm going to get rid of the 1/2 first. To get rid of multiplying by a fraction, we've learned that you multiply by the reciprocal. Multiplying by the reciprocal is where you flip-flop the numerator and denominator and multiply by that. So that's 2 over 1, or just a 2 that I'm multiplying both sides. So I'm left with 2a is equal to, well, my 2 times 1/2 cancels out, and I'm left with bh. So now I'm trying to get b by itself. B is attached to h by multiplication, so I can get rid of the h by dividing. So b is equal to 2a divided by h. And one thing to be really careful of is that whether a letter is capitalized or lowercase does make a difference. So this a is capitalized. It should be capitalized when you're writing it. The b and the h are lowercase. They should be lowercase when you're writing them because they represent actual things. A stands for area. Lowercase a does not stand for area. So those letters do make a difference, so make sure you're paying attention to that. Okay. Number 8, we are looking at now, trying to get h by itself. So again, let's get rid of that 1/3 first by multiplying by the reciprocal, which would be by times 3 or 3 over 1. If I do it to one side, I have to do it to the other side. Okay, so now I need to get h by itself. Pi r squared is attached to h by multiplication. Since all of it is attached by multiplication, I can get rid of all of it in one step by using division. So I can divide both sides by pi r squared. The pi r squares cancel out. I get h by itself. And on the other side, I have a 3v divided by pi r squared. That's getting h by itself. All right, number 9. Trying to get r by itself. This one's a little trickier. A lot of students' first instinct is to get rid of that v by using division or by using multiplication, but actually neither one of those is going to help because r is in the denominator. We want r in the numerator. So to get rid of r, we actually have to move it to the numerator on the other side. So I'm going to multiply by an r, or an r over 1. These r's cancel out, and then I can multiply the other side by r. Think about it like multiplying by the reciprocal. If I have a 1/2 times 2, those cancel each other out. So if I have something over r and I multiply it by r, the r and the dividing by r cancel each other out. Okay, so now I haven't gotten r by itself, but I've gotten r out of the denominator. So I'm able to then get r by itself now. So to get r by itself, I just need to get rid of that I. So I'll divide both sides by I, and I get r is equal to v divided by I. So if the letter you want by itself is in the denominator, multiply by that letter, multiply by that variable, move it to the other side then in the numerator, and then get it by itself. All right, let's try one more. Trying to get r by itself. N and t are both attached to r by multiplication. Since they're both attached by the exact same thing, I can get rid of them all in one swoop. So I'll divide both sides by the n and the t all at once to get r by itself, and I'm left with pv over nt. That's it. All right, so take a second, write your summary. How would you explain to someone else who hadn't watched this video how to solve a literal equation? Take a second, write some reminders to yourself, things you want to remember, star the problems you still have questions on, and come prepared tomorrow to get those questions asked so you can get them answered.